Hey guys, so we're getting close to the end here. We're doing scientific notation, multiplying and dividing. We're gonna put that video right there. Next week we'll do adding and subtracting, and then Unit 9, data and statistics, and that's 3 weeks. Oh, and then we'll have end of the year review, and then you made it. It's time for Algebra 1, but not yet. We're doing scientific notation. Scientific notation, do you think it's important? It's important, all right, because numbers can get very large, and we don't have time when we're dealing with large numbers to just write all the zeros. Also, it's not necessary in order to do the math, to write all the place values. We can use our rules of exponents and make our lives a lot easier. That's all it is. All right, so what is scientific notation? Scientific notation means that we're going to write one place value, the decimal point, and then all the other place values afterwards. Usually we only write 1, 2, 3, or 4 numbers after the decimal point, and then we kind of round it, and it's times 10 to some number. So the key is that we only want a ones place, and then everything else has to go behind the decimal. So how do we move the decimal point? We multiply by 10, right? If we multiply by 10, and you just move the decimal 1 to the right. How do you multiply by, how do you move the decimal point to the left? You multiply by 1 over 10. And that moves the decimal point 1 to the left. Of course, we don't think of it as 1 over 10. We think of it as 10 to the negative first, which we learned about, right? So when we're looking, and then 10 to the power positive first moves it to the right. So 10 to the second, that's going to move 2 to the right. I think you get it. 10 to the negative second. What's that doing? 2 to the left. All right, so that's a little, so I'm going to clear that. So we got 31 billion. The first question is, how many zeros is a billion? Well, a million is 6 zeros. A billion is 9 zeros. A trillion would be 12 zeros. Each of those illions is another group of 3. Okay, so 31 billion written in standard form would be like this. And we want to write it in scientific notation, which means 3.1 times 10 to some number. Okay, so again, we can only have one number in front of the decimal. So and the decimal point in standard form is at the end of the number. It'll be right here. So how many places does it have to move? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has to go 10 places. And so we want it to be 10 to the 10. Now I know I said to the right, left, but I mean when you're in scientific notation, multiplying by 10 moves the decimal backward to the right. But if we're kind of going backwards from standard form to scientific notation, then we're moving to the left with a positive. So let's make little charts because that's going to get confusing. All right, so we're going from, this is called standard form. And this is called scientific notation. So if we're going from standard form to scientific notation, standard form, scientific notation, if we're going that way, then 10 to the second move and 10 to the negative second moves the decimal to the right. And what I was talking about in my explanation earlier is starting in scientific notation and going to standard form. 10 to the second moves the decimal to right, and 10 to the negative second, just for an example, moves to left. Okay, so now we got, and this is scientific standard form, scientific notation. All right, so this would be 3.1 times 10 to the 10th. Let's start with a brand new one. How about this one? No one got it. Oh, this one either. Okay, so we want to put this into scientific notation. So we're starting in standard form, just like the last one. 1,000 means 3 zeros. So we want to take that decimal point and we want to move it 1, 2, 3, 4, 5 spaces. So that's 4.27. So that's going to be times 10 to the 5th. And then we can see if I was going to put this guy back into standard form, I would move the decimal 5 spaces, and I'd be back at 427,000. Let's do one. Maybe okay, like this. This one is in what form? Standard or scientific notation? This one is in scientific notation. So this time we're asking ourselves what would it look like in standard form. And so we look at the exponent. The exponent is positive. So that means we're going to move to the right. If we go from, look at your chart, from scientific notation to standard form, 10 to the second, a positive exponent moves it to the right. 10 to the 7th is going to move it 7 spaces to the right. So let's write our number. Then we're going to start moving that decimal point. 1, 2, 3, 4, 5, 6, 7. Put the new decimal point, and in all of these little waves here, or empty spaces, we're going to put a 0. And then that's our number. We got 4 zeros, 4, and so now I'm going to write it like that. And then we're going to go, and every 3, I'm going to put a comma. So we got 13,040,000. It looks like to me. All right, so that's a good little start, and then you can put your questions in the organizer from there. Okay, so now the next part is multiplying and dividing in scientific notation. So for this, we want to put our numbers in scientific notation before we start. So this is already in scientific notation. So this is in standard form. And so we want to put it into scientific notation. So what would that be in scientific notation? Well, the decimal point is right here, and it needs to be in between the 9 and the 4. 1, 2, there. So 9.4 times 10 to what? Well, I had to move the decimal point 2 spaces, so it's going to be times 10 to the 2. And so that is what that number looks like in scientific notation. Now, when we are multiplying these numbers together, do you remember what we do with exponents when we multiply numbers together? We add them. So we're going to add these exponents. So that would be 2 plus 3 is 10 to the 5th. And then with these numbers, we're just going to multiply them. So what is that? 18.8 is 9.4 times 2, 18.8. But notice that 18.8 times 10 to the 5th is not written in scientific notation. And it asks us to give our answer in scientific notation. Some of you may be saying, it's not in scientific notation. It's very close. But we have two numbers in front of the decimal, and we are only allowed to have one. So we need to write it like this, 1.88 times 10. So now you have to ask yourself, times 10 to the what? Times 10 to the 6th or times 10 to the 4th? Well, remember that when we're going from, when we're moving the decimal point to the left in scientific notation, we are actually requiring an extra move to get back to our numbered standard form. So I like to think about it like, what is the number in standard form? Let me make sense of the problem. So this number in standard form would be 1, 8, 8, and then that's 5. So that means 5 decimal point moves, but the first decimal point would be to move it after the 8. And then the other decimal point moves would be, what would they be? 1, 2, 3, 4, 5. So there's my 5 decimal point moves. And what do we put in these empty spaces? We put zeros. Okay, so that is the number, the answer in standard form. And what, so now we can see we just need one more, we need a 6th move, don't we? So it's really times 10 to the 6th. So if you need to move it one spot more to the left, then you actually have to add 1 to the exponent. But I figured that out by thinking about what does this number look like in standard form. Okay, so this one's going to take a little bit of practice. All right, but let's do one more, and that's division. So we know we're subtracting the exponents. Also, we got to get both numbers in scientific notation. Okay, so this one is already in scientific notation. And 2000. What is that going to look like in scientific notation? There's the decimal point. 1, 2, 3. I got to put the decimal point right there. That's 3 moves. So it's going to be 2 times 10 to the 3rd. All right. So now we would be dividing our numbers, and then we're going to subtract our exponents. So 6 minus 3 is 3. So it's going to be 10 to the 3rd. And what is 1.88 divided by 2? Good question. 1.88 divided by 2 is 0.94. All right, so now, are we in scientific notation? Almost, but as you know, we need to move that decimal. We need to move the decimal this time 1 in the other direction. So that's the opposite direction of the way I moved it in the last one, right? We had too many numbers in front of the decimal. This time we have not enough numbers in front of the decimal. In the last one, I had to add a number. So this time I have to subtract. So I could think to myself, what does it look like in standard form? But I also just kind of knew that I was doing the opposite of what I did in the last one. but let's still look at it in standard form. So times 10 to the third means we'd go 1, 2, 3. That would be 940. We fill in a 0. So this number in standard form is 940. And so what does that look like in scientific notation? Is that 9.4 times 10 to the second? Well, yes, because 9.4 times 10 to the second means 9.4, and then move the decimal 2 spaces, 940. So I know that this is our answer. All right, and the last assignment this week is a review assignment, and it's about transformations. Well, not that. Transformations interleave practice. So look at your organizer post for transformations from quarter 3 and make sure you don't have any red problems. If you do, make sure you redo those, update the organizer before trying this assignment, and you won't have to do it as many times. All right, let's get started. Complete those assignments and post in the organizer.